Hi everybody, 11 Institute welcomes all the students of Standard 10 to chapter number 11 of Science video lecture number 3. In the previous video lectures we have discussed about the structure of human eye, the power of accommodation of human eye, and in today's video lecture we are going to discuss about the defects of vision in the human eye and their correction. Right, defects of vision. Now this is sometimes misplaced or misunderstood with the normal eye problems. See, the eye problems or conditions or diseases are different than the defects of vision. Defect of vision involves problems with the image formation that is done by eye. Right. For example, we have to wear glasses. Some of us wear glasses in normal routine. Some of us wear glasses while reading something or while observing something which is near to us. Right. That condition is defect of vision. Fine. So the problems of eye, conditions or diseases of eye is a different thing, and defects of vision is a different thing. Fine. So today we are going to discuss about defects of vision. Let us see how do they arise. Sometimes the eye may gradually lose its power of accommodation, right? The eye will lose what? Power of accommodation. Not eye, but we can say that eye lens will lose the power of accommodation. In such conditions, the person cannot see the objects distinctly and comfortably. The person cannot see the objects distinctly and comfortably. In other words, we can say that clear image is not formed. Clear image is not formed. Why not formed? Because there is loss of power of accommodation by the eye lens. Thus, vision becomes blurred. Vision becomes blurred due to refractive defects of eye. Due to refractive defects of eye. Fine. So ultimately the main reason for this defects of vision is the eye lens is losing its power of accommodation gradually with age, sometimes before the age also. But these defects of vision arise only when there is loss of power of accommodation by the eye lens. Right. Now you should be able to correlate this. I will explain it over here. What is the role of power of accommodation? We have learnt it in the previous video lecture. What is the role of power of accommodation? In simple words, I can say the power of accommodation adjusts the focal length of eye lens. The focal length of eye lens. Due to the adjustment of focal length of eye lens, we can see the near and far objects clearly. We can see the near and far objects clearly, right? So when this power of accommodation is lost, the adjustment of focal length will also be lost, and in such case either we will be able to see the near objects clearly or we will be able to see the far objects clearly. Fine. So this is the role of power of accommodation as far as the defects of vision is concerned. There are mainly three common refractive defects of vision: myopia or nearsightedness, hypermetropia or farsightedness, presbyopia, right, which is combination of both or a different condition from these both. In today's video lecture we are going to discuss about these three: nearsightedness, also known as myopia; farsightedness, also known as hypermetropia; and the last one is presbyopia. Fine. So let us now discuss about nearsightedness, and please be very clear. This is one of the most important parts of this chapter from where you can accept a sure short question. Right. So be attentive, watch this and apply your logic. Sure. So let us discuss about myopia, which is also known as nearsightedness. Now, what happens in case of myopia or nearsightedness? Let us read. See, the name itself suggests nearsightedness, the condition of eye in which one person is able to see the nearby objects clearly, but he has problem in viewing or in seeing the objects which are situated far away from him or her. Fine, I will repeat it again. Nearsightedness. Nearsightedness means you can easily see the objects which are near to you, right? Whose object distance is less. But we have problem in seeing the objects which are situated far from us. Such a condition is known as nearsightedness. નજીકનું જોવામાં કોઈ પણ ટાઈપની તકલીફ થતી નથી, but દૂરનું જોવામાં તકલીફ થાય છે. Such condition is known as myopia. A person with myopia can see nearby objects clearly. Can see nearby objects clearly, but cannot see distant objects distinctly. Distant objects દેખાશે but not clearly. બહુ clearly દેખાશે નહીં, blurred image દેખાશે. A person with this defect has far point nearer than infinity. This is the problem. Generally, what is the near point of eye? 25 centimeter. What is the far point of eye? Infinity. Matlab, if a person is standing over here, right, and this is his near point at 25 centimeters, and this is his far point at infinity, right, for a normal person. But now if this person is having myopia, this person is suffering from nearsightedness, it can see the nearby objects clearly, not problem, but he or she cannot see the object situated far away clearly. What does it mean? That there is some problem with the far point. For normal person, the far point is at infinity, but for such a person, the far point is near or yet more near. Why? This person can see the nearby objects clearly, that's why. So his far point is affected. The far point is generally at infinity, but for myopic persons, it is nearer to the person, right? Let us read ahead. In a myopic eye, the image of distant object is formed in front of retina instead of retina itself. This is the main problem. Generally, the image is formed on retina itself. But for a myopic person, the image of a distant object is formed in front of retina. Now, image is not formed exactly on retina, hence we are not able to see that object clearly. See, just by reading the sentences, it is impossible to explain this. So we will have to draw some diagrams and we will have a crystal clear understanding about this. So if you have not understood anything from these three lines, don't worry. Right, I will explain this to you with the help of a diagram. But yes, you have to remember one thing. Nearsightedness means you have no problem in seeing the objects which are near to you, but you have problem in seeing the objects which are situated far away from you. Fine. નજીકનું જોવામાં કોઈ પણ તકલીફ થતી નથી, દૂરનું જોવામાં તકલીફ થાય છે. શ્યોર, આ ટાઈપની કન્ડિશનને શું કહેશું આપણે? નિયર સાઇટેડનેસ. હવે શું કામ થાય છે, શું પ્રોબ્લેમ છે એક્ઝેક્ટલી, અને એનું સોલ્યુશન શું છે, that I will explain to you with the help of a diagram. Fine. So consider this. I will not draw the entire eye, but I will draw over here, suppose retina. Right, what is this? This is retina. And suppose this is eye lens. I am not drawing the entire eye. Suppose this is eye lens. And now suppose there is an object over here, which I can say it is near to the lens. The object is near to lens. So parallel rays will come from the object, they will get refracted, and we get an image on the retina. Don't be confused about the rules over here, that it will go through the, it is parallel to the principal axis and it will come out of the focal point. Don't apply such rules now. Just think that you are getting an image exactly on the retina when when the object is near to the lens. I hope this is clear to you. Right, so this is scenario number 1. Now let us consider again, I will draw over here retina, right, and I will place the object far away, right. So I can write over here the object is far from lens. The object is far from lens. Now if the object is far from lens, this lens has to accommodate. In order to see this object clearly, which is situated far away from the lens, the focal length of this lens should change. This lens has to become thin, right? So in case of normal eye, this lens will become thin like this. See, this is thick and this is thin. Focal length is more. So rays will come from here and they will get focused on the retina like this. And you will get a clear image on retina, right? The conditions that we have discussed over here are for a normal eye. Now let us talk about a person who is suffering from myopia. Such person does not have any problem in seeing the objects which are near to lens. So this condition will be same, or this diagram will be same. But if a person has myopia and that person has to see a distant object, suppose this is a distant object, here I am having retina, and this lens is kept over here, but it will remain as it is. Why? Because this lens has lost its power of accommodation. Right, this lens is not changing its focal length appropriately. Why? Because it is suffering from myopia. So now the rays will come from here and they will get focused over here like this. And here we get an image. Right, we get an image over here. Now just understand this. This is a normal eye. This is also a normal eye. In case of normal eye, when I want to see an object which is far, the lens should become thin. The lens should become thin, or its curvature should decrease. Its curvature should decrease. So in case of normal eye, if I can see a near object clearly, I can see a far object also clearly, because this lens is becoming thin. It is reducing its curvature, and hence previously also I was getting image on retina. Now also I am getting image on retina. But if a person is suffering from myopia, he or she can clearly observe the nearby images. There is no problem. But there is problem in seeing the far objects. Why? Because this lens is not changing its focal length. This lens is not changing its curvature according to the requirement. Right, the lens should become thin, but here the lens is not becoming thin, it remains thick only, due to which we do not get the image on retina, but we get an image in front of retina. we get an image in front of retina. I hope this is clear to you. These refracted rays, this is refracted ray number 1, refracted ray number 2, they should meet on retina, but they meet before retina. They meet before retina. Now, in order to solve this, I have to make this lens thin, but that is not possible. Lens is present inside the eye. We are not able to change its focal length artificially. What else we can do? We can see that these rays meet instantly. If these rays meet after some time like this, right, then we can get a proper image formation. So for that purpose, what we do is we place over here a concave lens. What do? We place over here a concave lens. This concave lens will diverge the refracted rays. આ રેઝ પેલા ફટાફટ મળી લેતી હતી, હવે આ બંને રેઝ ને થોડુંક દૂર લઈ જવામાં આવશે. બંને રેઝ ને દૂર કોણ લઈ જશે? કોન્કેવ લેન્સ. વાય? બીકોઝ ઇટ ઇઝ અ ડાયવર્જિંગ લેન્સ. આ બંને લેન્સીસ ને થોડુંક દૂર લઈ જશે, સચ ધેટ ઇમેજ પેલા અહીંયા બનતી હતી ફરી પાછી અહીંયા રેટિના ઉપર જ બને. I hope this is clear to you. Fine. Now let us see what is given in textbook. In case if anybody is feeling any problem in remembering this, just think that those people who generally wear glasses in routine, જે normally બી ચશ્મા પહેરીને ફરતા હોય છે, એને near sightedness છે. એમને નજીકનું જોવામાં કોઈ તકલીફ નથી, બટ દૂરનું જોવામાં તકલીફ થાય છે, તો એ કન્ટિન્યુઅસલી ચશ્મા પહેરીને રાખે છે. ફોર એક્ઝામ્પલ મી, હું હંમેશા ચશ્મા પહેરીને રાખું છું. વાય? મને દૂરનું જોવામાં તકલીફ છે. મને નજીકનું બધું બરાબર દેખાય છે, બટ મને દૂરનું જોવામાં તકલીફ છે. શું કામ તકલીફ છે? ભાઈ, મારી લેન્સ રિક્વાયરમેન્ટ પ્રમાણે થિન બનતી નથી, થીક જ રહે છે. તો હવે જે ઇમેજ છે, that image should be formed on retina in normal cases, but for a person having myopia, that image is formed before retina. તો આ બંને રેઝ ઇન્સ્ટન્ટલી ન મળે અને થોડીક દૂર જઈને મળે, એના માટે આપણે અહીંયા ડાયવર્જિંગ લેન્સ લગાડવી પડશે. તો જે ગ્લાસીસ હંમેશા હું વેર કરું છું, they are nothing but that is a concave lens, such that these refracted rays do not meet instantly and they meet after some time due to the divergence. I hope this is clear to you. Let us now read what is given in the textbook. This defect may arise due to excessive curvature of lens, or in other words, I can say that lens remains thick. The lens remains thick. Excessive curvature. લેન્સ આમ જાડી ને જાડી જ રહે છે, બરાબર ને? એ આમ પતલી બની જતી હોય કોઈ જ પ્રોબ્લેમ ન થાય, બટ પતલી બનતી નથી. So there is excessive curvature of the lens due to which this problem arises. Another reason is elongation of eyeball. Right? Elongation of eyeball. Eyeball ની width વધારે હોય, eyeball ની size વધારે હોય, then also it is possible that nearsightedness might occur. What is the correction? This defect can be corrected by using a concave lens of suitable focal length or suitable power, which will bring the image back onto the retina and thus the defect is corrected. બરાબર ને? જે ઇમેજ પેલા રેટિનાની ઇન ફ્રન્ટમાં ફોર્મ થતી હતી, એને વળી પાછી આપણે થોડી પાછળ લઈ જાશું with the help of a concave lens. રાઈટ? આઈ હોપ ધીસ ઇઝ ક્લિયર ટુ યુ. તો કોઈ વ્યક્તિ જનરલી પૂરેપૂરો દિવસ ચશ્મા પહેરીને રાખતું હોય, એ ભાઈને નિયર સાઇટેડનેસ છે, અને નિયર સાઇટેડનેસ માટેનો ઇલાજ શું છે? ટુ યુઝ અ કોન્કેવ લેન્સ, or it can be asked in other manner also, and we have to remember that it can be corrected by using a diverging lens. Fine. I hope this is clear to you. In case if this is still not clear, don't worry, everything will be clear to you by the end of this video lecture. So this is the first defect of vision that we have seen. Now we will see the second defect of vision, that is the far-sightedness. Right? Far-sightedness. Exactly opposite of near-sightedness. In this defect, we are able to see far objects clearly. We are able to see the far objects clearly. So there is problem in seeing nearby objects. There is problem in seeing the nearby objects. Right? So that is the meaning of far sightedness. દૂરનું બધું બરાબર દેખાય છે. નજીકનું જોવામાં તકલીફ થાય છે. This generally happens in old age. You know, some people have that pair of glasses like this. You know, આવી એક મસ્ત મજાની આમ ડબ્બી જોઈ અહીંયાથી આમ ઢાંકણા વાળી ખિસ્સામાં રખડતી હોય બધાના આને ઓપન કરો એટલે નાનકડા આમ ચશ્મા બહાર આવે ને જ્યારે કંઈક વાંચવું હોય. Suppose if elderly people wants to see something in their mobile phone, or if they want to read newspaper, or if they want to read something in a book, they will immediately take out a small pair of glasses and they will wear that. They will read something and they will again keep those glasses after the reading. Normally they do not wear glasses. They wear glasses only when they want to see something which is near to their eyes. It means that they can easily see something that is situated far away. Right? They can easily see something that is situated far away. Right? But they have problem seeing something which is quite near to them. Such a condition is known as farsightedness. It is also known as hypermetropia. It is also known as hypermetropia. So let us now discuss this. A person with hypermetropia can see distant objects clearly, right? Can see distant objects clearly, but cannot see nearby objects. So here the problem is with near point. In case of hypermetropia, the problem is with near point. In case of myopia, the problem was with far point. For normal condition, the far point is infinity, right? But for myopia, it is nearer than infinity. For hypermetropia, we discuss over here, for normal eye, the near point is 25 centimeters. But for hypermetropia, the near point is greater than 25 centimeters. Right? This is very much important for 1 mark question. You should be quite clear with this. In hypermetropia, there is problem with near point. Generally, the near point is at 25 centimeters for normal eye, and the far point is at infinity. But if you are having myopia, you are having problem in seeing the far away objects, then your far point will be nearer than infinity. And in case of hypermetropia, your near point will be at a distance of greater than 25 centimeters. This is very much important. I request you to write this somewhere in your CW, in heading, or anywhere else. This is bit important. Fine. Let us now discuss with the diagram what happens in case of farsightedness. Right. So again, I will draw a lens over here. And I will draw a retina over here. So this is retina. And this is our eye lens. And suppose we are observing a far object. So now rays come from this far object and they get focused on retina, and we get a sharp image. We get a sharp image. There is no problem. Right? Now, if our eye is normal, if our eye is normal, and we bring the object nearer to the lens, here again the retina is as it is, right? But you have brought the object nearer to the lens. Now if you bring the object nearer to the lens, this lens will become thick. The lens will become thick, and again the image will be formed exactly on retina. the image will be formed exactly on retina for a normal eye. So a normal eye can easily see the objects which are located far, and it can also easily see the objects which are located near, because when the eye is observing far objects, the lens is thin. When the eye is observing near objects, the lens is thick. But what happens if a person is suffering from hypermetropia? That is the point of discussion. Hypermetropia. What happens when a person is suffering from hypermetropia? See, this condition is same, because a person having hypermetropia can see distant objects clearly. Same condition will get repeated over here. But the same person, if I keep the retina over here, or if we imagine that here is the retina, an object which is placed quite near to the lens should become thick, but here the lens is not becoming thick. It is remaining as it is. In such cases, parallel rays will come like this, but they will get focused behind the retina. They will get focused behind the retina. So a clear image is not formed on retina, and hence when anything is placed near to the lens, a hypermetropic person cannot see it. The nearby objects are not clear. Why they are not clear? The only reason is the lens has lost its power of accommodation. The lens was observing the far object, no problem, the lens is thin. But when the object comes near, the lens should become thick. But the lens does not become thick as per requirement. The lens does not become thick as per requirement. It remains thin only, due to which the image is formed behind the retina, and we do not get a clear image over here, and hence we have a blurred vision. I hope this is quite clear to you. Fine. Let us now understand with the help of example. Causes of defect. These defects arise because the focal length of eye lens is too long, or in case I can say that the lens is thin, or the focal length is more. It does not become thick as per the requirement. Second reason is the eyeball is too small. The two reasons exactly opposite to that of myopia. How we can solve this? See, here is retina. Here is our normal eye lens which remains thin. Here is our object which is near. And we have this parallel rays, and we get an image over here like this. Now we want that these rays meet at a later point. We want them to meet over here only. We want them to meet early. Right. In order to do this, we require a converging lens. And what is the converging lens? A convex lens. So when we use a convex lens over here, these rays will get focused over here early, because the lens will be now converged. They will be brought nearer to each other, and we will get an image on the retina. So such defect is corrected with the help of a convex lens of suitable focal length. Right? The defect can be corrected using a convex lens of suitable focal length or power. Right? Such that the image is now not formed behind the retina, but the image is formed on the retina. I hope this is clear to you. So this is about farsightedness. Let us now see the third defect of vision, that is presbyopia. Presbyopia is also known as aging hypermetropia. Right. Sometimes it is also the combination of both myopia and hypermetropia. Let us see what is given in textbook. The power of accommodation of eye usually decreases with aging. For most people, the near point gradually recedes away. Pela near point 25 centimeter hato, then the near point increases from 25 centimeter. Hence, there is problem in seeing the nearby objects. They find it difficult to see nearby objects comfortably and distinctly without corrective eyeglasses. This defect is called presbyopia. તો આ તો એક ટાઈપનું હાઇપરમેટ્રોપિયા જ થયું. બરાબર ને, but this is in the person who are aging. The hypermetropia that we have discussed in the previous slide, that is for all the people. But if it happens naturally with aging, બરાબર ને, એક સિમ્પલ એક્ઝામ્પલ છે ભાઈ, 15 વર્ષના બે જણા છે, તો આ ભાઈને નજીકનું જોવામાં કોઈ પણ ટાઈપની તકલીફ નથી થતી, આ ભાઈને સપોઝ થતી હોય, રેર ચાન્સીસ. But if there are two people with the age of 75, both of them will be definitely having problem in seeing the nearby objects. Almost. Right, such condition is known as presbyopia. Don't be confused with hypermetropia. Right, let us move ahead. Cause of the defect: due to gradual weakening of ciliary muscles and diminishing flexibility of eye lens. બરાબર ને, eye lens does not become thick as per the requirement. Why eye lens does not become thick as per the requirement? Because ciliary muscles are not doing so. Right, this is the main reason for this defect, that there is loss of contraction and relaxation of ciliary muscles. The flexibility has been reduced. Sometimes a person may suffer from myopia and hypermetropia both. Such people often require a bifocal lens. Right, they often require a bifocal lens. They may suffer from myopia also and hypermetropia also. They require a bifocal lens. ક્યારે આવું જોયું હશે તમે કે ભાઈ આ કોઈના ચશ્મા છે, સપોઝ બહુ સારું ડ્રોઈંગ નહીં થઈ જાય, but suppose these are the glasses of a particular person, right? તારક મહેતા ઉલ્ટા ચશ્મા, and you see that this entire surface cloud, and you can see that there is some different portion over here. આવું તમે જોયું હશે, રાઈટ? આ નજીકનું જોવા માટે અને આ ઉપરનો પોર્શન દૂરનું જોવા માટે આવા ગ્લાસીસ તમે પહેરતા જોયા હશે. So such people are suffering from both myopia and hypermetropia. They have problem in seeing the near objects also. They have problem in seeing the far objects also. So they require concave lens and convex lens both at the same time, and such people use a bifocal lens like this. Right, they use a bifocal lens. બરાબર ને, this for observing nearby objects and the upper surface to observe the far away objects. This is a combination of both concave and convex lens. એક બહારની સાઈડ વળેલું હશે, અંદરની સાઈડ વળેલું હશે, for people suffering from both myopia and hypermetropia. Correction of this defect: how can you correct presbyopia? Presbyopia can be corrected with the help of a bifocal lens which contains both concave and convex lenses. The upper portion consists of a concave lens. I have shown it to you. It facilitates the distant vision, દૂરનું જોવા માટે, and the lower part is a convex lens and it facilitates the near vision. બરાબર ને, આવી રીતના ગ્લાસ છે આપણી પાસે અને એની અંદર આવી રીતના આમ છે, તો upper portion is concave, lower portion is convex. This upper portion is used to see the distant objects, the lower portion is used to see the nearby objects. So this is about presbyopia. Generally occurs with aging, ઉંમર થાય પછી. બરાબર ને, કોઈ પણ વ્યક્તિ તમને નાની ઉંમરનો હોય 20 25 30 વર્ષનો, એને તમે આવા લેન્સીસ પહેરતા નહીં જોવો. આઈધર એને નજીકના નંબર હશે ઓર એને દૂરના નંબર હશે. But as age progresses, the ciliary muscles lose their ability to contract and relax, and hence they are not able to make the lens thin or thick as per the requirement, due to which such defects arises, which is known as presbyopia. Fine, I hope this is quite clear to you. Let us now see an animation and understand what happens in all the defects of vision. So we will now discuss all the defects of vision again, and whatever we have discussed, that will be very much clear with the help of this animation. Fine, so let us now see with the help of an animation what happens in case of the defects of vision. Right, we know that the near point is at 25 centimeters. See, you can see nearby objects clearly, but when you move it far away, you cannot see this clearly. So this condition is known as nearsightedness, where you can see the nearby objects clearly, but you cannot see the far objects clearly. Right, let us see now what happens. Nearsightedness, farsightedness, and presbyopia. We need not to discuss this astigmatism. Let us see about far-sightedness. Right, we can easily see the far away objects, but the nearby objects are not clear. You can see a blurry image over here. What happens in such cases? Right, this is the eye lens. It is thin or a short eyeball. The rays come and the image is formed behind the retina. Right, the image is formed behind the retina in the case of far-sightedness. So I will remind you over here again. Right, when we talk about the far-sightedness, right, when we are talking about far-sightedness, what is the reason? The lens does not become thick. The lens remains thin. This is the problem. The focal length is more. Right, this is the main problem for far-sightedness, that the focal length is more. Right, due to this the image is formed behind the retina. Now if I want that these rays are meeting over here, they should meet over here before. Right, so these rays should be converged more such that the image is formed on the retina. So we need convergence over here, and for doing convergence over here we have to provide a converging lens or convex lens over here to solve this problem. Right, let us now see this. Yes, so we use a convex lens to solve the defect of far-sightedness. A convex lens of suitable focal length will be placed over here, the rays will be converged, and now we get an image over here instead of getting an image over here behind the retina. This is the solution for far-sightedness. Right, now let us see what happens in case of near-sightedness. In case of nearsightedness, we can see the nearby objects clearly, but when it goes behind, we cannot see it. We cannot see the far objects clearly. Such condition is known as nearsightedness, and in such cases, the lens remains thick. You can see a thick lens over here, or a elongated eyeball, or a elongated eyeball. These are the two problems in the cases of short-sightedness. Let me explain it over here. Here, the lens remains thick. It does not become thin as per requirement. It does not become thin as per the requirement. It remains thick, due to which the image is formed in front of retina. Right, let us see. The image is formed in front of retina. See, these rays are coming and the image is formed before the retina over here. So now what is our requirement? Our requirement is that these rays which get focused over here should get focused later on like this. So what we want is divergence. We want that these rays should be away from each other. We want divergence over here, and for divergence we will use a diverging lens which is also known as concave lens, such that they will keep these rays away and these rays will meet on a later note exactly on the retina. Let us see what happens. Right, we want an image on the retina, so for that we will use a concave lens of suitable focal length, and when that is placed over here, the image will be formed here, right? The rays that diverged, and we get an image exactly on the retina. Now astigmatism is not important for us, so I will skip it, and we will directly move to presbyopia. Or if you want to see, let us see astigmatism also. That is fine. Just watch it. A person has blurred vision, whether in observing near objects or far objects. A person is constantly having blurred vision, right? What is the reason? Cornea or eye lens, both of them are not perfectly spherical. Generally they are spherical, but in such people, that is not spherical. The eye lens is not of a proper shape. There is problem over here. You can see it is not of a proper shape, and due to this, there is not an exact image formation on retina. So a cylindrical lens is used. What is this? This is a cylindrical lens like this, such that it is a part of a cylinder. A cylindrical lens is used to get a proper image over here for astigmatism. Not in our syllabus. Yes, presbyopia is in our syllabus. All people cannot read clearly. They need a glass like this to read clearly. Right? The lens is hardened. Fine. The ciliary muscles are weak, due to which the image is formed behind the retina. So one thing is clear, that presbyopia is nothing but a new form of hypermetropia. Right? Be very much clear about it. Presbyopia is nothing but a new form of hypermetropia. If it is in normal people, if it is in younger people, then it is hypermetropia, but it is not common. In case of elder people, it is quite common, and hence it is known as presbyopia. This is the difference that you should know quite well. Let us move ahead. Right? Convex lens or a bifocal lens we have to use. Right? See, this is a bifocal lens. Sure. So with the help of a bifocal lens, I will show you once again. See, this is a bifocal lens. The upper portion is concave and the lower portion is convex. So when you want to read something, you will observe it from here, and when you want to see something which is far away, we will observe it from the upper part of the glass. This is how we can correct the defect of presbyopia. I hope this is quite clear to you. So now this is the end of the topic today, but we have to write some question and answer. So this is the first question. Explain defects of vision and their correction. There are 3 pages. This is the page 1. Right, you have to start writing from here. This is a very important 4-mark question. Right, very much important. These diagrams also you have to draw. Right, and it is clearly as per the textbook. So pause the video. I will just move the slides. You have to again rewind, pause the video and write this answer down exactly in your CW. This answer is of 3 pages. This is the first page. Explain the defects of vision and their correction. This is the first page. Myopia is explained. Pause the video, write this. Then on the second page, hypermetropia is explained. This is page number 2. Pause the video, write this much. Once you finish writing this much, the answer is not yet over. You will write this information given on page number 3 about presbyopia. So this is page number 3. So there are 3 pages. I repeat it once again. This is the first page. This is the second page. And this is the third page. Now you finish your answer. Yet there are more question answers. These are given in the textbook 1, 2, 3, 4, and this 8 and 9 are given in the exercises at the end of the chapter. I will show you the answers. These are the first 3 answers. See, there are 4 questions over here, but we have already seen this in the previous video lecture. Right? So this will be our number 1, this will be number 2, this will be number 3, this will be 4, and this will be 5. which I am showing you now. So these are 1, 2 and 3. Question answer, question and answer, question and answer. They are quite simple and example based. Write them down in your CW. They have to be written in your CW. Once you finish writing this, these are number 4 and number 5. This also you have to write in CW. Fine. Once you finish writing this, your work is over. So here I end this video lecture, and we will now meet again in the next video lecture continuing this chapter further. Till then, take very good care of yourself, but please write this question and answers. Right? In all, you have to write 6 answers today in your CW. Fine, please complete the CW, else you will have problems reading the question and answers or searching for the answers at the exam time. Please keep your CW completed. Don't then, please complete the CW. Fine. We will now meet in the next video lecture. Thank you very much for listening. Take very good care of yourselves. Goodbye.